Hello, everybody. Technical issues are fun. Anyways, this is Embrace the Chaos, Composable Data Systems with Fewer Asterisks. I'm Matt Topol, and I'll just introduce myself so you have a reason to actually listen to anything I'm saying. I primarily work on the Apache Arrow project. If you don't know what that is, you will shortly. But I also work at Voltron Data and also contribute to the Go implementation of Iceberg. And I'm on the PMC for Apache Arrow and wrote the book on it, as you can see here. It is the first book on Apache Arrow. I used to be able to say it's the only one, but a couple of former colleagues wrote a book using Arrow with R, so it's no longer the only book. But there it is. This is actually the second edition, which just came out at the end of September. So I'd like to start this talk with a small little quote from Mary Shelley with, invention, must be humbly admitted, does not consist in creating out of the void, but out of chaos, which is what covers a lot of what I want to go about here, where, you're not us as developers and people building systems, we're not creating things out of nothing. We're standing on the shoulders of everything, but we have all of these options that we can utilize, all of these different tools and things that already exist. And whenever you're going to go build a system, there's really two major ways people try to build beta systems. You're either getting something or pieces off the shelf, or you're building it from scratch. And historically, building it from scratch was the only way to do it because everything was always packaged as these single monolithic DBMS, and that's just the way you built a data platform. You had to build the whole thing from the ground up. But our current landscape makes it much easier to avoid that. Now, why do we want to avoid that? Well, when you're just grabbing a platform off the shelf or you're building it from scratch, there's a couple things that everybody is concerned about, and you want to look at what's available out there. And that leads to them building the whole thing from scratch. They want to avoid lock-in. You want to avoid vendor lock-in because eventually, if you want to move on, you're going to have to migrate all that data somewhere else to an entirely new system. You can't just incrementally do things. And so out of fear of that, let's just go build a whole thing from scratch. There's also the problem of scale. You want to hit a certain scale to process your data for your use cases, and you're unsure of, or you're pretty sure that this whole platform that's available isn't going to scale well enough for you. And so you build the whole thing from scratch. Or just a matter of performance requirements. So the other thing is people wanting to change their current systems. Why are people building new data systems instead of using all the existing ones? Well, they're trying to hop onto the AI bandwagon. They're the whole arms race of, LLMs, things can be faster, scalable. Everybody's just is afraid of missing out on all of this AI hype. And with the rise of all the GPU and accelerated hardware, everybody's just trying to jump on and say, we got to change our system to take advantage of all this. And then they go and build the whole thing. So what's the alternative to building it from scratch? These composable data systems and composable modules, really. And what do I mean by that? So whenever you're dealing with really any data system at all, there's effectively three primary layers that are always going to be seen in some form or another. You have an interface, the user interface layer, which maybe that's the server endpoint to connect to your service, or maybe that might be a literal user interface. Then you have some kind of execution engine, some kind of compute. And obviously you have your data storage. Now, for any data system at all, you're always going to see some variation of these three layers, probably some other layers in between, but effectively, you'll always see these. And the ability to use different tools and utilities that already exist for those purposes and swap them in and out as a composable system is what I'm talking about. And the only way you can really do that is by operating on standards. And in this case, when we're talking about these data systems, there's three primary standards that you need to be able to do this. You either need a standard way, you also need a standard way to represent your query plans. You need to standardize on how you access your database, your data storage, and your setups. And you need to standardize on the in-memory representation of your data. If you can standardize on these three things, then you get access to compose your system out of existing modules that all use the same standards. So by utilizing these open standards, because vendors are going to try to lock you in, vendors that create monolithic things use proprietary instead of open standards often, so that you can't compose new modules. And so you turn to things that are open source. You have projects like Apache Calcite, which will get you your SQL query parsing right out of the gate for you. You don't have to do any extra work. I mean, you do have to do some work to create whatever plan you want, but the actual parsing is right there. Or maybe you want to use Apache Iceberg for your storage, your table format. Okay? For your execution engine, maybe you use Trino, maybe you use Apache Data Fusion, DuckDB. The point is that by using these standards, you get interoperability. All of these components and modules can talk to each other and just work. And standards are everywhere. I mean, go as far back as the internet itself. HTTP. Browsers all understand the HTTP standard, and that enables us to use whatever browser we personally prefer because everything understands the same protocol. Same thing goes for your data systems. And this is not a new idea. The whole idea of doing this modular, interoperable, composable systems is not a new thing. With the advent of the way that the ecosystem of tools and utilities are now, we're moving away from the old monolithic DBMSs and decomposing the old database systems. And it's been happening for decades, just slowly. But all the enterprise legacy stuff stays in these monoliths and makes it more difficult to change. And at that point, once you have your standards and you have these documented, reusable agreements so that you can have these components all connect without extra effort, without extra work by your developers, by your users, you can then use two specific things that are meant by connect when we're talking about data systems: exchanging data and communicating messages and instructions. And what currently ends up happening a lot is you end up with these data silos. And I'm sure many of us have experienced the issues with these data silos where you're working on some application and you're trying to build a new system and you realize you need data from this system over there and there is no good way to actually get it. You're in the bad data place at that point because you're like, okay, how do I get this data over here and that one over here? And you start, well, this is what you have to do. So you find a way to make it work and circumvent some security issues or circumvent some compliance restrictions to make it work because that isolation screwed you over with, I want access to that. It informs and creates these silos of data. Whereas if you base your systems on these standards, it makes it much, much easier to connect systems together and work as a group. And you avoid wasted time, wasted costs. You avoid inconsistency and outdated data because you're not doing copying of this data over to there or doing extra caching that you didn't need to do just because everything is in the wrong place. The other benefit there is that by using these modular and composable pieces to componentize your data system, you can have your developer team only has to actually focus on the spot that you were trying to innovate on. Whatever your company, your business, your project, whatever thing you are is going to be your secret sauce, your business logic. You can focus on just doing that instead of having to build an entire platform, because all of the other components can just come from open source bits and bobs that exist, and then you slide in whichever layer is going to be your secret special thing, and you only have to spend developer time on that. You don't have to spend developer time building out an entire platform when you can just modularly compose bits to have the platform for you. And so standards are there crucial. Standards are what make all of this able to actually happen. And then you see things like, for example, Streamlit switched their internal way of representing and shifting data around to utilize Apache Arrow, utilize the libraries, and they were able to delete 1,000 lines of code of their special proprietary stuff by just switching to a standard and leveraging the standard library for it. And they saw enormous speed up. Now we talk about standards a lot, and the issue that makes it so difficult is that standards are kind of invisible. Standards aren't flashy, big application things, and so people don't go about frequently making new standards because they're hard to find, they're hard to get funding for. But us as developers find those standards to be crucial to making our jobs easier and making it work. And of course, the proliferation of standards becomes our famous XKCD comic here that everybody is likely familiar with, that whenever people talk about standards, they get worried about this. It's proliferations. So it's not just any standard. You need to pick a good standard. And what makes something actually a good standard? And so, at least for my opinions, what I find is this kind of like 5-pronged setup of how you can evaluate a standard in terms of whether it's actually going to be a good long-term choice. Is the standard open? Does it have an open source license? First, foremost question. Because if it doesn't have an open source license, if it's not open, then you are going to be at the behest of whatever company actually owns it. Okay, so if we have an open standard, what about community? Is there an active community contributing to the standard? Because like any other piece of software, standards can stagnate. And then you have to make a choice of, do I deviate from the standard because I need these features or not? But if there's an active community, then the standard can evolve. It can be changed. It can adopt new things as a community and move forward so that it stays relevant. Once you have a nice community, is there a governance model on the standard? Whether it's the Apache software way of doing things, whether it's Linux Foundation, or whatever governance you choose, there needs to be some kind of governance around it. You don't want it to be where one person single is the only person who makes every decision on, does this get merged? Does the standard change? I say no. Well, you want a governance model with multiple people, multiple vested interests from different areas, different companies, different places, so that no one individual can actually control the whole standard. After you have your governance, are people actually using the standard? Because a standard that nobody uses, well, why is nobody using it? Is it actually useless? Does it actually not enable anything? Or if it did, when people start using it, is it just that they don't know about it yet? And so, you need a standard that people are actually willing to publicly adopt. And by having that, that gives you more confidence in the future of it. And once you have your adoption, once you have your governance, once you have your open standard, people start building ecosystem projects around it. Is there a nice ecosystem around that project, that standard? And then if you have all of these, you can be pretty sure that that's a good standard to get behind. Who remembers the modern data stack image thing? I got a couple hands. Yeah, this went around a lot over the last couple of years of showing, the modern data stack of all of these bits and pieces. But the part that flew under the radar, in my opinion, is the fact that the reasons why you have this proliferation of tools and utilities, where you have the modern data stack that can all talk to each other like this, is because of open standards. They all have various standards that they share, that they agree on, that you can use, that they can then talk to each other across. And then you can then leverage these modern data stack components to build a data system by leveraging those standards. So let's look back again at the diagram from earlier. I'm just going to swap what's the most prominent here and point out again, if you have a standard for each of these three things, you have a componentized modular stack to build off of. And it's all based on the interoperability. So, a lot of times when we're talking about technology decisions and choices, we talk about, which should we go with, which thing should we choose, which engine should we support. I propose that instead, ask the question, how do we get everything to talk together, to talk to each other easily? Because if everything can talk to each other easily, it doesn't matter which one we choose, because if it turns out to not be the one we wanted, we can just swap out another one for a different use case, because it can talk the same thing. And you get that composability. The real complexity and costs going to start to rack up if you wait on that interoperability, because then you have to do the migrations, you have to build adapters, you have to build glue code to connect this to that, to this to that, when you get to the point that you need to integrate another system. If you start from the point of make things talk to each other interoperably, then you're going to save yourself a lot of headaches down the line. And that brings us to, well, what are some existing standards that can be used? Well, I'm glad you asked. So the first one I'm pointing out here is Apache Arrow. Yes, slight plug, because like I said, I'm a PMC member and wrote a book on it. But Arrow itself is, seen a lot and spreading across the ecosystem a ton. And the reason why many of you may not have heard of it a lot, because Arrow is very invisible. It's a lower level standard because it's a memory format. And many of you probably are utilizing tools and utilities that integrate Arrow, but they aren't shouting it or anything, because you're not using it, you're using it indirectly through them. And so to get us all on the same page before I, go on my little tangents here, quick primer on what Apache Arrow is. See, I tell you what it is. Like I said, Arrow is an in-memory, column-oriented data format. Open source, Apache license, so on and so forth. The idea being that when you have your data systems and you're passing data from one system to another, from one node to another, hell, from one runtime to another, huge cost is serializing and deserializing that data every time it goes from one place to another. Well, what if you didn't have to do that serialization and deserialization? The format in memory for Arrow is identical to the format on the wire in the network. No serialization, deserialization required. It's also column-oriented, so it's super efficient for vectorized compute. It's very friendly to SIMD, and highly efficient, and it's used extremely in a lot of different engines already. Now, if you're not familiar with what I mean by column-oriented to columnar, it's pretty simple. It's just a matter of the way you actually lay out the data in memory for a table. You know, struct of arrays versus array of structs. It's very straightforward, simple idea. If you look at, you look at the table. If you look at think of it as a contiguous buffer of memory. You can either put column A, B, C of row 1, column A, B, C, row 2, or you can do all the rows for column A, all the rows for column B, all the rows for column C, all contiguous like that. And by doing it that way, it enables vectorization without having to copy data away. And it also enables highly efficient I/O. You can get significantly lower memory usage because you only need to actually access and play with the columns you need, and significantly faster computation. I'm going to rush through this a little bit because I'm running low on time. Now, I did say we had to go, what makes a good standard? I gave you a bunch of metrics to use for what makes a good standard. So if you look at Arrow, it's open source, Apache licensed, vibrant community. It's got you've got nearly 1,000 unique contributors on GitHub. You've got 13K stars. So it's a very active community. It uses the Apache governance model. PMC, committers, and so on. Adoption. Okay, well, underlying memory format of the Polar's data frame library is Arrow. DuckDB's internal memory representation is nearly indistinguishable from Arrow. Dremio, InfluxDB, both internally use Arrow, Apache Data Fusion. And those things also interact and interoperate with Arrow. And so on and so forth. So we got our adoption. Okay, now the ecosystem. Well, utilities and tools. Well, DuckDB exposes Arrow interfaces for zero-copy communication. Dremio exposes Arrow Flight RPC, and so on. So yeah, we got our 5 things. Cool. Check, check, check. So there's a good standard. And when we look at the tasks in your data set application, there's 2 main tasks: moving the data from one place to another and processing that data. Processing it is going to be compute bound based on, your GPUs, your CPU, or whatever hardware you're using. And then moving it is always going to be based on I/O bound and your data transfer. Okay, so how can we leverage Arrow to do our compose system? For our standard query plan representation, there's an open standard substrate. It's a way of representing relational algebra plans, logical plans, for compute. That separates your parser from your execution engine, from your optimizations. It gives you a new layer you can stick things into and get generalized utilities and tools out of. So we got our representation there. Arrow as our in-memory column format. There you go. And then for the database accessing, there's ADBC, Arrow Database Connectivity. If you're familiar with JDBC and ODBC, ADBC is a similar concept. You've got one single client API that the application writes against, swappable drivers. The big difference is that the data is using Arrow format, which means it's column-oriented. Why does that matter? The vast majority of data computational analytics systems now are all column-oriented. JDBC and ODBC connectors are row-oriented, which means we're taking, in 90% of cases, you've got column-oriented data compute, transpose everything into rows to send it across ODBC and JDBC, and more than half the time, the application just transposes it back into columns for post-processing, visualizations, and whatever. Well, ADBC, same idea, except it stays in column orientation the whole way through. You eliminate that transpose cost, you reduce copies, so on. DuckDB implements the ADBC interface. You can load DuckDB as an ADBC driver and have everything flow through super fast. We also have drivers for Snowflake. We're working on the BigQuery one, so on. So we got our connectivities, and you can see that more of the adoption here of people utilizing Arrow. I'm just going to move a little forward here. And so when it comes to like embracing this chaos of all of these options and choices and things you can pick, I like to go along the idea here of this little evaluation rubric. If anyone's familiar with like Maslow's hierarchy of needs, well, this is your data hierarchy of needs. Okay? Whenever you're trying to build your system, looking at a particular piece, a particular component, whether you can or should use something, think about this hierarchy. Is it modular? You know, do you have standalone swappable pieces and parts? Are all the parts interoperable? After I swap them out, do they still talk to each other easily? Can you customize those parts? Because it's not one size fits all. All of us as developers know that. All of us as developers know that even when you're taking open source things off the shelf, you're going to run into use cases that don't fit what you need. You're going to want to make modifications. It needs to be customizable. And once it's customizable, can you then extend it? Is it extensible so that you can add new things to it as you need them? And so we can embrace this sprawl with our little MICE acronym here. We want to avoid the bad data place. Okay? When I talk about when I'm saying like the sprawl that I'm referring to, is when you have all these one-off solutions. You know, I know most of us have probably been in that situation where it's like, everything works except for this one thing. And so you do a one-off fix just to fix the one thing. And then, you know, a couple months later, we do a different one-off. And all these one-off solutions accumulate over time until eventually you just have this giant house of cards that just collapses. And you end up with teams doing things that they shouldn't be doing. Okay? Your data analysts shouldn't be creating new databases. Your data scientists shouldn't be building data engineering workloads. But if that's what you have them doing, they're going to be doing these band-aid solutions all over the place instead of doing what the expertise should be. And so we want to reduce that sprawl. You know, I have that tweet up there that I really love because half the time you listen to anything engineers or us developers talking about, and it just sounds like this to most people. You know, I just duped my way through a hive, and I've been living in a powder keg giving off Apache sparks. It's ridiculous, but we all know what it means. Well, most of us know what it means because we understand the technologies, but yeah. Anyways, I like that tweet. But anyways, the point here is when you're building your system, what are the asterisks? What are the pieces that are going to be our edge case, that we're going to get hung up on? Okay, we look at our query here, our system there. Well, we have our UI to the server, to the database. Where's the hangups? What possible hangups could we get? Well, what about if we want to combine results across different queries? What about multi-database queries that we want to federate? Okay? So how do we wish all this worked? Well, we wish it was just pick a connector, send a query, execute, get it ready, and return the results. We wish that it was just that easy. No edge cases, no asterisks, no exceptions. So what gets in the way of that? Well, most databases are proprietary. Is the database available for your environment? You know, you could potentially use ODBC and JDBC, but then you have extra copies, slowdowns. When you talk about different, client queries, client APIs, and drivers, there's lots of variability in behavior across those drivers. Which one do you pick? And so on. Again, I'm going to skip through again because I'm low on time here, but you get the point that I'm trying to make, I hope. And so we can reduce and make that sprawl smaller by leveraging everything I've been talking about in these standards and composable modular systems. So I mentioned ADBC. Here's my quick slide on it. I don't need to harp on it much more because I'm low on, because of, kind of rush through it, but you get the point there, hopefully. You can see that with ADBC, you can just swap out the different drivers, but everything on the client side can utilize that Arrow standard we were talking about. And this works for whatever standard you want to talk about and think ideas when you standardize on a composable system. This is the DuckDB example I mentioned earlier, showing the direct benchmark. And I really like this benchmark because DuckDB as an embedded database means that there's no network overhead here. This is insert a million rows, select a million rows, use ADBC or use ODBC, which means that we've isolated the cost of those transpositions, going from 28 seconds down to 0.7. Now, transporting the data across networks. The Arrow project provides Arrowflight RPC, an RPC protocol for data transport. Now, if you don't want to use Arrowflight RPC, you can use standard REST calls and just pass Arrow data that way. And it works. Because you're avoiding the serialization, you're avoiding the deserialization, but the benefits of picking a protocol, you want to know what, the point here is not, you should definitely always use Flight. The point here is picking a standard protocol. Okay, by picking a standard protocol, you don't need to create your own protocol, which many people think it's easy to do, and then you try it and you're like, wow, all these cases I didn't account for. Just like you should never roll your own crypto library. Same idea. So by picking an existing standard protocol, you don't need to build your own client drivers. You don't need to develop your own client API. And then bits and pieces become swappable again and modular. And then when you're talking about dealing with database interactions, you have Arrowflight SQL. And if your database exposes Arrowflight SQL as an interface, you got Arrow standard data communication. There's already a Flight SQL JDBC database driver, ODBC Flight SQL driver, ADBC Flight SQL driver. Whatever environment you need it to use in will just work. And you don't have to build your own custom client stuff. Okay, I'm just going to real fast skip through the next couple slides here. So as I mentioned, the advantages of using ADBC and Flight SQL. I'm not going to repeat myself. When I talk about ADBC and Flight SQL, I'm talking about an API versus a protocol. And then you end up with the ability of customizably swapping things out like this. So this is just my last little quote. We as engineers try to make complex problems easy. Instead, we should make working on complex problems easy. Make it easy to work on the complex problems rather than focusing on trying to make the problem itself easier. Because then we'll just get another complex problem. Yeah, so at the end of the time here, so most of the content from this talk was adapted from a series of blog posts that Voltron Data put up last year called the Composable Codex. There was also a Composable Manifesto white paper that was published last year too, that I highly recommend looking up. If you want to learn more about Arrow, ADBC, Flight SQL, and all that, The docs are very, very helpful. And, shameless plug, my book is extremely useful. I have one more copy that I'll have with me tomorrow that I can just hand out to someone. If you come up to me, first person gets a nice signed copy, I'll just hand it to you. As long as you actually are going to use it, want to learn from it. And that's it, really. That's it. Thank you. Now, I guess I'll let you ask questions until they kick me off, if anyone has any. I'm not seeing any raised hands, so everybody understood everything I just said. Awesome. Feel free to come up to me at any point. Come chat, come talk with me. I'm friendly. I try. So thank you, guys.